Hello future professionals, welcome to day 31 of our top 100 coding question analysis. Today we are challenged with the question to find the roots of the quadratic equation. Now that our problem statement is defined, let's have a hands-on experience. We know that the general expression for quadratic equation is ax square plus bx plus c equal to 0, where a is x square's coefficient, b is x's coefficient and c is constant, right? And we find the discriminant, that is b square minus 4ac, which we call it as discriminant, which helps us to find nature of the roots. That is, when b square minus 4ac is equal to 0, we conclude that the roots are real and equal, right? The second condition is that when the discriminant, that is b square minus 4ac, is greater than 0, then we conclude roots are real and distinct, right? The third and the final condition is that when the discriminant b square minus 4ac is less than 0, then we conclude that roots are complex, right? And we must also know the formula to find the roots. The formula to find both the roots is minus b plus or minus root over b square minus 4ac divided by 2a, where the root 1 is equal to minus b plus root over b square minus 4ac divided by 2a, and root 2 would be minus b minus root over b square minus 4ac divided by 2a, right? Now that we have looked at the formula to obtain the roots of the equation, we shall solve practical examples. First, we shall solve an equation where the roots are real and distinct. That will be our first example. Here, the value of a is 1, b is 7 and c is 12, right? Now let's find the nature of the roots, that is b square minus 4ac, right? That gives us the discriminant. B square is 7 square minus 4 into a is 1, c is 12, right? We get 49 minus 48, that is equal to 1. As our discriminant is greater than 0, we conclude that our roots are real and distinct, right? Next, we shall find the roots, that is root 1 is equal to minus b minus 7 plus root over b square, that is 7 square 49 minus 4 into a is 1 and c is 12, right? This is entirely divided by 2 into 1, that is 2a. That gives us the result minus 7 plus root over 49 minus 48 divided by 2, that is equal to minus 7 plus 1 divided by 2, that gives us the result minus 6 by 2, that gives us the root 1 equal to minus 3, right? Now let's find the second equation, the second root, that is minus 7 minus root over 49 minus 48 divided by 2. That gives us minus 7 minus 1 divided by 2. That results in minus 8 divided by 2. That gives us the root 2 as minus 4. Now that we have found both the roots, root 1 and root 2, hence we say that the roots of the equation with the coefficients as 1, 7 and 12 is minus 3, minus 4, right? Next, we will solve an equation where the roots are real and equal, right? Here, the value of A is 1, B is 2 and C is 1. Let's find the nature of the roots. Let's find the discriminant for that. Discriminant is equal to minus b square minus 4ac, that is 4 minus 4 into 1 into 1, that is equal to 0. Now my discriminant is equal to 0, so I conclude roots are real and equal, right? Now if I find any one of the root, it will be equal to the second root. So let me find the first root, that is minus b plus root over 4 minus 4 into 1 into 1 divided by 2a, that is 2 into 1. That gives me minus 2 by 2, that gives us the root minus 1. Now as we know the roots are real and equal, root 2 is equal to minus 1. Now let's find the roots of the equation which are complex. Here the value of A is 2, B is 2 and C is 1, right? Let's find the nature of the roots, that is we shall find the discriminant, that is b square minus 4ac, that equal to 4 minus 4 into 2 into 1, that gives us 4 minus 8, that is equal to minus 4. Since my discriminant is less than 0, I conclude the roots are complex, right? Next, let me find the first root. R1 is equal to minus b plus root over b square minus 4ac divided by 2a, that is equal to minus 2 minus plus of root minus 4 divided by 2. 2a is nothing but 2 into 2. Let me rewrite this. It is 2a, a is 2, so we get the resultant as 4, right? Now let's solve this. We know that root over minus 4 is equal to root over minus 1 into 4, that gives us I into 2, right? So the resultant is minus 2 plus 2i divided by 4, that gives us the result 1 by 2 plus 1 by 2i, right? Root 2 would be the same root, but the sign would be minus, right? Now that we have derived the roots of all different types of equation, so let's derive the logic out of the solved examples. The logic is that first we shall get the coefficients a, b and the constancy from user. Second, we shall calculate the discriminant, that is b square minus 4ac, to find nature of roots, right? Next, we find the roots of the equation of the quadratic equation using the formula minus b plus or minus root over b square minus 4ac by 2a, right? After we find both the nature and the roots of the equation, we shall print both nature of roots and the roots itself, right? Now that we have printed both the roots and the nature of the roots, let's terminate the program. Now that we have understood the logic, let's put it into practice by coding our program. We import the CMath module to work with complex numbers. Next, we import the math module to work with integers, floats, and etc. Right? First, we have defined a function to get the user's input. I name the function getUserInput. Here, we get the value of a, b, and c from the user and return those values. Next, we have defined a second function named as findRoots, where it gets a, b, c as its parameters. Next, we calculate the discriminant, that is b square minus 4ac, right? Next, we check whether the discriminant is equal to 0. If it is equal to 0, we print the roots are real and equal. Then we find both the roots. Next, if the root is greater than 0, then we print the roots are real and distinct. Next, we calculate both the roots. Else, if the discriminant is less than 0, then we print the roots are complex. Next, we find the root 1 and root 2. Here, we use the CMath module as we are working with complex numbers. Next, we print the roots. Now that we have defined all our required functions, let's call those functions. I call the getUserInput function and store the return value in the variables a, b, c respectively. Next, I call the findRoots function and pass a, b, c as the argument. Now that we don't have any errors or warning signals, let's run the program. Let me check for a real and distinct roots. The program says the roots are real and distinct and the roots are minus 3, minus 4, right? Next, let me check for real and equal roots. The program tells me the roots are real and equal, and it says roots are minus 1, minus 1. Next, let me run it for complex roots. It says the roots are complex and the roots are minus 0.5 plus 0.5j, minus 0.5 minus 0.5j. Thus, we have successfully completed our program. I hope you would have got the best out of this video. I recommend you subscribing our channel to get more such interesting videos. I also recommend you to like and share the video if you find it supportive and interesting.